Building a secure and scalable SaaS application on AWS EKS, Step-by-Step Deployment Guide. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Introduction, project overview and objectives. In today's cloud-centric world, deploying a secure and scalable software as a service, SaaS, application is critical for success. AWS Elastic Kubernetes Service, EKS, provides a powerful platform to achieve this by leveraging the power of Kubernetes for container orchestration. This podcast will walk you through deploying a SaaS application on AWS EKS, from setting up your environment to finalizing the deployment with secure access, preparing the AWS environment, installing essential tools. Before starting, ensure that your local development environment is equipped with the necessary tools. AWS CLI, for managing AWS services from the command line. Kubectl, Kubernetes command line tool for controlling Kubernetes clusters. Xtl, a CLI tool for creating and managing EKS clusters. Terraform, for infrastructure provisioning and management as code. If you haven't already, install these tools on your machine. Having the latest versions will help avoid compatibility issues. Setting up IAM user and permissions. Creating an IAM user with the necessary permissions is crucial for managing AWS services securely. Set up an IAM user with programmatic access, and attach policies such as administrator access, or create a custom policy with the specific permissions needed for EKS, S3, and DynamoDB. Navigate to the IAM console. Create a new user with programmatic access. Attach the administrator access policy or custom policy. Save the access key ID and secret access key securely. Provisioning S3 and DynamoDB with Terraform. Use Terraform to provision AWS resources like S3 and DynamoDB, ensuring consistency across environments. Here's a basic setup. Create a Terraform configuration file for S3 and DynamoDB. Define resources like AWS_S3_bucket and AWS_DynamoDB_table. Initialize Terraform and apply the configuration. Terraform init. Terraform apply. Creating and configuring the EKS cluster. EKS cluster creation with Xtl. Creating an EKS cluster with Xtl is straightforward. Define your cluster configuration in a YAML file and run the following command. Xtl create cluster fcluster config.yaml. This command provisions the EKS cluster, configures nodes, and sets up necessary networking components. Verifying cluster connectivity. Once the EKS cluster is up and running, verify the connectivity using kubectl. Kubectl get nodes. This command should return a list of worker nodes, confirming the cluster is operational, implementing ingress control and load balancing. Installing the AWS Load Balancer Controller. The AWS Load Balancer Controller manages AWS Elastic Load Balancers for a Kubernetes cluster. Install it using Helm. Helm repo at https://aws.github.io/xcharts. Helm install AWS Load Balancer Controller x/AWS Load Balancer Controller. Set cluster name equals your cluster name. Set service account.create equals false. Set service account.name equals AWS Load Balancer Controller. Verifying load balancer deployment. Ensure that the load balancer controller is deployed and functioning by checking the Kubernetes services. Kubectl get services. Enabling secure application access. Creating IAM roles and service accounts for pod execution. Create an IAM role and associate it with a Kubernetes service account to grant permissions to your pods. Create an IAM role with the necessary policies. Create a Kubernetes service account linked to this IAM role. Containerizing the application with Docker. Dockerize your application by creating a Docker file that defines the environment, dependencies, and commands to run your app. Build and test the image locally. Docker build your app name. Pushing Docker images to ECR push. the Docker image to Amazon Elastic Container Registry, ECR. Authenticate Docker to ECR. AWS ECR get login password region. Docker login username AWS password Stettin your account ID dkr.ecr.region amazonoz.com. Tag and push the image. Docker tag your app name latest. Your account ID dkr.ecr.region amazonoz.com/your repo name latest. Docker push your account eddkr.ecr.region amazonoz.com/your repo name latest. Deploying the application and configuring ingress. Deploying the application with Kubernetes manifests. Create Kubernetes deployment and service manifests to deploy your application. Apply the manifests to your EKS cluster. Kubectl apply fdeployment.yaml. Kubectl apply fservice.yaml. Setting up Route 53 domain and SSL certificate. To enable secure access, set up a domain in Route 53 and provision an SSL certificate using AWS Certificate Manager, ACM. Ensure that your domain correctly points to the load balancer created by the AWS Load Balancer controller. Configuring ingress rules. Configure ingress rules to route traffic from your domain to the application. API version. Networking.k8s.io/v1. Kind, ingress. Metadata. Name, app ingress. Spec, rules. Host, your domain name. HTTP, paths. Path type, prefix. Backend service. Name, your service name. Port. Number, 80. TLS. Hosts. Your domain name. Secret name, your TLS secret. Finalizing the deployment. Creating Route 53 alias record. Create an alias record in Route 53 to point your domain to the load balancer. Go to Route 53 console. Create an alias record set for your domain pointing to the ALB. Testing the deployed application. Finally, test your deployed application by visiting the domain in your browser. Verify that the application is accessible, secured with HTTPS, and functioning as expected. Conclusion. Deploying a secure, scalable SaaS application on AWS EKS involves several steps, from setting up the AWS environment and configuring EKS to deploying and securing your application. With this podcast, you can confidently build and deploy your SaaS application on AWS, leveraging the power of Kubernetes and AWS services. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.